Catholic High Mid-Year Exams 2021 Primary 6 Paper 2. Let's go through the first question. Michelle spent $6 more than Nicole. They spent M dollars in total. How much did Michelle spend? So the first statement shows there is a quantity difference or total value difference. So whenever there is a quantity difference, or in this case, total value difference, you always begin by drawing a model. So you have Michelle, you have Nicole. Michelle spent $6 more than Nicole. So this is a standard comparison model. And they spent a total of M dollars. So I put M dollars here. So this is $6. So this is a standard comparison model. You always use the total, take away the extra, which in this case $6. So M minus $6. And if you divide it by 2, this is what you get, one of this. So the question is asking for Michelle. So Michelle is this. So it will be just this plus $6. So the answer is the dollar sign is already here, so you don't have to indicate any dollar sign in your answer. So M minus 6 over 2 plus 6. So that's the answer. Now let's go on to the next question. We clear this and go on to the next question. Okay. Next question is, let me read this one from when we clear away the dots. Reading. Okay. So the average of 3 different numbers is 210. All the numbers are 3-digit whole numbers. One of the numbers is 180. What is the largest possible difference between the other 2 numbers? So first, the question provides you the average of 3 numbers. And the average of 3 numbers is 210. Given average, and the number of items, you'll be able to find the total. 210 multiplied by 3 numbers, and then you will get 630. This will be the total value of the 3 numbers. In the question, it also provides that one of the number is 180. So if I use the total, I take away the value of one of the number. What is left is 450. And this is the value of total value of the remaining 2 numbers. Okay, so there are 2 numbers. The next, this 450 is made up of sum of the value of 2 numbers. The question wants the largest possible difference. And we know that from this question, they are all 3-digit numbers. The largest possible difference will happen when one of the number is the smallest and the other number is the largest it can be. So the smallest 3-digit number is 100. So if 100 is the smallest of the 2 numbers, the other number would simply be 450 minus 100, and that will be 350. So the 2 numbers will be, one of them is 350 and the other one is 100. So the question asks the difference between the 2 numbers. It will be 350 minus 100. Answer is 250. Okay, let's go on to the second, next question, question 3. So in this question, Wayne drove a car from 1 hour for the first 75 kilometers of a journey. He completed the remaining 45 kilometers of the journey in half an hour. What was Wayne's average speed for the whole journey. To find the average speed of the whole journey, the formula is total distance divided by total time taken. So in this question, there's two parts of the journey. The first part of the journey, distance traveled. For the first part of the journey is 75 kilometers. The second part of the journey, Wayne drove 45 kilometers. So the entire journey, the total distance covered is 120 kilometers. Let's look at the time. The first part of the journey, Wayne took 1 hour. 1 hour. That's the first part of the journey, 1 hour. The second part of the journey, Wayne took half an hour. So the total time taken for the entire journey is 1.5 hours. So based on the formula to find average speed, total distance over time, it will mean it is 120, which is the total distance, over the total time, which is divided by 1.5. Use your calculator, you will get 80. So answer is 80 kilometers per hour. Let's continue with question number 4. So question number 4. In Singapore, so in the figure below, PQR and TUS are identical right angle triangles. The keyword is identical, huh? So they are the same. The total area of the unshaded part is 292. So this plus this is 292. The total area of the unshaded part is 292. So one of the unshaded part will be 292 divided by 2. That will be 146. Let me indicate 146 in the diagram. So this is 146, and this will also be 146. All right, let's continue. The total shade area of the unshaded part is 290. Find the area of the shaded parts. So now we know the height and base of the triangle. The height, let's pick this triangle PQR. The height will be 23. It's taken from here since they're identical. The base is 16. So the area of the triangle PQR is half times base 16 times height 23. And that will give you 184. So with 184, which is a triangle, area of this triangle, if I take away 146, what I will be left with will be the shaded portion of the figure. So I use 184, take away 146, I will have 184 minus 146. Let me use, I don't have a calculator. Let me do it. And it's 4 minus 146. 14, 6, 2. And then this is 14 minus 6. 8. It will be 28. Find the area of the shaded part. Let me try again. There's a careless mistake somewhere. 184. No, sorry, this is 7. So this is 3. 38. So answer is 38. All right. Let's go on to the next question. Question number 5. Aaron and Brenda had the same number of coins at first. Each child has had a mix of 20 cents and 50-cent coins. Aaron had 7 more 20-cent coins than Brenda. Both children spent money at a shop, and Aaron spent more money than Brenda. So in these two statements, pick whether they are true, false, or not possible to tell. So first thing I'll do is I'll try to gather as much information I can have from the question. So first thing I see is that Aaron and Brenda both have the same number of coins. So I can actually draw a model here to represent the number of coins Aaron and Brenda had. So since they have the same number of coins, I'm going to draw the same bar for both of them. Now, this question, I'd like to continue with this question. That was a slight technical issue. Some of the things I drew wasn't reflected. So I'm going to update my drawing. Now, in this question, it says that it says that Aaron had 7 more 20-cent coins than Brenda. So if we look at 20-cent coins that Brenda has, it has to be somewhere behind this line. Okay, so the difference is 7 coins. The rest of Brenda's coins will be 50-cent coins. All right. So looking at the first statement A, Aaron had more money. More money, we are talking about value, than Brenda at first. This statement is false. Let me explain to you why. So if you look at Aaron, Aaron has more 20 cents than Brenda, but Brenda has more 50 cents than Aaron, and they have the same number of coins. So with this, we can say that Brenda has more money than Aaron. So this statement is not true. Now let's look at the statement B. Statement B says Brenda had more coins than Aaron at first. So let's look at the Brenda had more coins than Aaron at the end, not at first, at the end. This is after both children spent money at a shop and Aaron spends more money than Brenda. So if both spent money at a shop and Aaron spent more money than Brenda, the statement says Brenda had more coins than Aaron at the end. So let's test a scenario where this statement is false, and let's test if there's another scenario where this statement can also be true. If we can have 2 scenarios where the statement can be false and can also be true, then the answer will be not possible to tell. So let's test it out. The statement says that Brenda had more coins than Aaron in the end. Can we have a scenario where both spent the same number of coins and Aaron still spent more money than Brenda? It is possible. That scenario is Brenda spent 1 50-cent coins and Aaron spent 1 20-cent coins. In this scenario, we will satisfy the statements that Aaron spent more money. Sorry, I'm talking about Aaron spent more money. So in this statement, Aaron will spend more money than Brenda, and yet in the end they have equal number of coins. So in this case, the statement B is false. Let's look at another scenario. In this scenario, we can have Aaron spent more money than Brenda. Aaron spent 60 cents. Brenda spent 120 cents. So Aaron will spend more money than Brenda, but because Aaron spent 3 coins and Brenda spent 1 coin, in the end, Brenda will have more coins than Aaron. So in this scenario, it is true. So we can have 2 different scenarios. One is false and one is true. And that is why for question 5b, the answer is not possible to tell. Okay, let's continue with question number 6. So this is a bar chart. What we do is, whenever we encounter a bar chart, we always indicate the value of each of the bar onto the diagram. So I hope you have no problem indicating the value. This is 120. This is 160. It's pretty easy to look and track the lines. 240. Mango, we are not sure yet. Now, what was the ratio of the number of children who choose chocolate ice cream to the total number of children who choose vanilla and strawberry ice cream? So we have chocolates to vanilla plus strawberries. Okay, chocolate is 120. Vanilla plus ice cream 160 plus 240. You get 400. Simplify, 3:10. Very simple. So answer is 3:10 for question 6a. Let's look at 6b. Let me clear this and move on to 6b. Let me adjust this a little bit so I have more space. So in 6b, 1/5 of children who choose mango ice cream, 1/5 of children choose mango ice cream. Draw the bar that shows the number of children who choose mango ice cream in the graph above. So we know that the chocolate ice cream was 120. People choose chocolate is 120. Vanilla is 160. Strawberry is 240. So there's a total of 520 children who did not choose mango. If 1/5 chose mango, it will mean that 4/5 didn't choose mango, and therefore 4/5 is 520 children. 1/5 will be 520 divided by 4. That will be 130, which is the number of children who chose mango. 130 will be here. 50, 100, and 1, 2, 3 here. Okay, so that's the answer. Let's continue with question number 7. Richard needed to fold 356 paper cranes for a charity event. He folded 9 paper cranes each day from Monday to Friday, and 17 paper cranes each day on Saturday and Sunday. Starting on a Saturday, on which day of the week did Richard finish folding 350 paper cranes? Okay, so we have Saturday, Sunday, each 17 paper cranes. Then for the rest of the week, Monday, Tuesday, Wednesday, Thursday, Friday, it is 9 each day. So in 1 week, the total number of paper cranes folded will be 2 times 17 plus 9 times 5. Okay, use your calculator, you will get 79. So every week, Richard folded 79 paper cranes. In total, Richard folded 356 paper cranes. So how many weeks is that? 356 divided by 79. Use your calculator, you will get 4 remainder 43. All right. So 43 is not 1 week. Okay, 1 week will require 79 paper cranes. So there are 43 paper cranes folded over a few days, but less than a week. So starting from Saturday, Sunday, and then you will get 9. So this is Saturday, this is Sunday, and this will be Monday. So the answer is Monday. Let's continue with question number 8. So in this question, the figure is made up of figure 1 and figure 2 are all made up of 4 identical rectangles. All right. So when a figure in a question like this, normally what is required is to know what's the relationship between the length and the breadth. So from here, from figure 1, you can see that the length of the rectangle is equal to 3 of its breadth. So we can do this. Length to breadth is 3:1. So the length is 3 units, the breadth is 1 unit. Okay. Now, look at the question again. In the figure, the area of figure 1 is 192 cm2. So 192 is made out of 4 rectangles. If you divide it by 4, you get the area of one of the rectangle, 48. Okay. Okay. Earlier we said the length is 3 units and the breadth is 1 unit. So this is 3 units. Just look at this, 3 units, right? And this will be 1 unit, 2 units, 3 units, also 3 units. So in other words, in other words, this is a square. Okay, this is a square. So area of this square will be equal to one of the rectangle multiplied by 3, 144. So 144 is the area of this yellow square. Given area, you can find the sides because 144 is equal to 12 times 12. So this will be 12 centimeter. 12 centimeter. 12 centimeter is 3 units. 1 unit will be 12 divided by 3. 4 centimeter. So the breadth of the rectangle is 4 centimeter. So I can say this is 4 centimeter. This is 3 units, right? So this is 3 times 4. 12 centimeter. This will be 12 centimeter too. So find the height of figure 2. The height of figure 2 will be 12 plus 4 plus 12, and that will give you 28 centimeter. So let's continue with question number 9. So the answer is 28 centimeter, okay? 28 centimeters is the answer. Okay. So question 9 is a units and parts question. Let's record the question using ratio. So there were some black bits and white bits in the box. the number of black bits was 2/5 of the number of white bits. This we can record as this black to white will be 2:5. And after 12 black bits and 44 white bits were taken out of the box, this is how I record. 12 black bits taken out, so black minus 12, white, take out 44, so white minus 44. The number of black bits left in the box was 2/3 of the number of white bits left. So black to white will be 2:3. Okay. So if you look at what is recorded, you'll notice everything has changed. There is no common base between, there's no common base for total, no common base for differences, and black has changed, so is white. So there's no common base. In a scenario like this, you use the units and parts method. All right. So let's create the two statements. The first statement we'll create will be for the black bits. Let's focus on the black bits. Get the color right. So the black bits, you start off with 2 units of black bits. You remove 12 black bits and end up with 2 black bits. So it's 2u minus 12 black bits, ended up with 2 parts of black bits. Now let's look at the white bits. So we started off with 5 units of white bits, take out 44, and then end up with 3 parts. So 5 units minus 44 ended up with 3 parts. So the approach to solving this kind of question is to always make the parts the same. Okay, so let's make the parts the same. The lowest common multiple of 2 and 3 is 6. So for this, I'll have to multiply by 3 to get 6 parts. I must multiply 3 across. So I get 36, and I get 6u. 3 parts to get 6, I multiply by 2. So across, I'll multiply by 2, minus 88, 44 times 2, 88, 10u times 2, no, sorry, 5u times 2 is 10u. Now we can see that both statements are equal to 6 parts. So because they are both equal to 6 parts, I can join them together. Okay, I will move all the units to one side. All the whole numbers to the other side. So what I have left will be 10u minus 6u is 4u. 88 minus 36 is 88 minus 36 is 52. So 4u is equal to 52. 1u will be equal to 52 divided by 4. And that you get 13. Read the question again. How many bits were left in the box? We are talking about in the end. So do not use 13 multiplied by 2 plus 3, 5. Do not use 13 times 5. You do that, your answer will be wrong because 13 is units and it's not parts. So 13 is not applicable to 2:3 in the end. Okay, 13, however, is applicable to 2 and 5 over here. 2 and 5 units over here. Okay, so the question is, how many bits were left in the box? So you're talking about both black and white. So at first, there is 7 units of black and white bits over here. 7 units of black and white will be equal to 7 times 13. 7 times 13, let's see. 7 times 13 is 91. So there are 91 black and white bits at first. To find the n, you must take away 12 and you must take away 44. Minus 12 minus 44. And your answer is 35. So this is the number of bits in the end. So let's continue with question 10. So this is a working backwards question. Eugene and Frank had a total of 272 stamps. Eugene gave 1/3 of his stamps to Frank. Frank then gave 1/5 of his stamps to Eugene. In the end, each of them had the same number of stamps. How many stamps did Eugene have at first? So this is a pretty easy question. Yeah? So we start off with Eugene and Frank. And because it's a working backwards question, and we know that total at every stage is the same. So to begin with, I'll draw two empty boxes. I'll fill in the figure later. So this is supposedly what Eugene will have at first. So what happened? What did Eugene do? Eugene give 1/3 minus 1/3 of what he had and give it to, okay, and give it to Frank. What comes next is Frank then gave 1/5 of his stamps to Eugene. So Frank will have, so I do not know that, leave it empty for a moment. Frank will minus 1/5 of what he had and then give it to Eugene. So in the end, let's find out what they have in the end. In the end, they both have same number of stamps. So we know that at every stage, the total stays as 272 because total don't change when they are giving to each other. So in the end, if they are equal, so what I can do is I can do 272 divided by 2 and split 272 equally between the two of them. So each of them is 136. So to work backwards, I always start with the person with a negative, the person that give away. Okay, do not start with plus 1/5. Go start with minus 1/5. Always start with the person or items that has given away his parts to the other person. So 136. If I have given away 1/5, if Frank has given 1/5, then 136 must be 4/5. 4/5 of, so 136 got to be 4/5 of what is what Frank has left. So 4/5 of Frank's bits must be equal to 136. 1/5 of Frank's bit will be 136 divided by 4. And that will give you 34. And all of Frank's bit will be 5/5. So that will 34 times 5 and gives you 170. So what I write here is 170. So if I use 272 minus 170, I will get what Eugene had. So 272 minus 170 is 102. So this is 102. Okay, we completed filling the boxes for the second stage. Now let's continue to find what is at first. So as I was mentioning earlier, we always begin with the person that has a negative, okay, minus 1/3. So if I minus 1/3 of Eugene, this must be 2/3 of what is left. If you minus 1/3, you're left with 2/3. So 2/3 of Eugene's bits must be equal to 102. 1/3 of Eugene's bit will be equal to 102 divided by 2, 61. Sorry, 51. Or 61. 51. Okay. Now the question is, how many stamps did Eugene have at first? Eugene is at first is 3 of Eugene. That will give you 51 times 3. And the answer is 153. Let's continue with question 11. So let's read question 11. 4 teams of pupils sold bottles of sweets at a carnival. They sold a big bottle of sweets for $7 and a small bottle of sweets for $4. The table shows the number of bottles of sweets sold by 3 of the teams, A, B, and C. Okay. which of the three teams collected? Let me clear. Okay, which of the three teams collected the least amount of money? What was the amount of money collected? So what you do is you literally need to calculate. Do not use visual to estimate which has the least or which has the most. So I will calculate one by one. Okay, let's look at team A. Team A got three small. So team A, three small will be 3 multiplied by the value of a small bottle is $4. The value of a big bottle is $7. Okay, so 3 times 4 plus 12 times 7. So 3 times 4 plus 12 times 7. Let's see. $96. Okay, let's look at B. B will be 13 times 4 plus 6 times 7, and it's $94. C will be 8 times $4 plus 9 times $7, and you get 95. So from this, you can see that the team that which of this team collected this amount of money. So from this, you can see that team A collected the least amount of money. Let me get my mouse right. And so you can see the team that collected this amount of money is team A. Okay, team A. I'm making my pen. So team B. Team B collected the least amount of money. Team B. Okay, that's part A answer. Let's look at part B. Second part of part A answer. What was the amount of money collected? So the amount of money collected is 94. So the second part of the answer will be $94. So this A and this B. Oh, sorry, this is still A, but second part of A. Now let's look at part B. Team D sold 3 times as much as Team D sold 3 times as many big bottles, 3 times as many big bottles as sweets as small bottles of sweets. So this statement tells you the quantity of bottles of sweets sold by comparing the small quantity sold for small bottles and big bottles. So we can actually draw a quantity value table here. Okay, so you have big bottle, small bottle. So you have quantity, value, total value. This is just for understanding of the question. In exams, you don't really need to draw, but I do encourage you to draw so that you can understand the question better. So the statement says, Team D sold 3 times as many big bottles of sweets as small bottles. So I can, in quantity terms, is 3:1. So every time I sold 3 big bottles, I will sell 1 small bottle. The value will be the value of each bottle of big sweets will be $7. Each bottle of small sweets will be $4. So if you multiply 3 times 7, you get 21. 1 times 4, you get $4. So this is one group of bottles of sweets, big and small bottles of sweets sold by the team D. So by team D. Okay. So in one group, team D will receive $21 plus $4, and altogether, one group has a value of $25. Team D sold a few groups and collected $225. So in $225, it consists of how many groups? You divide it by 25, you get 9. So team D sold 9 groups of bottles, 9 groups of such bottles. All right. Question is, how many are small bottles? So it's 9 groups, and every group there are 1 small bottle. So 9 times 1. Answer is 9 small bottles sold altogether by team D. Okay. Let's continue with question number 12. So if you look at this question, one of the common mistake people made is that they assume AFC, this line, as a straight line. Visually, it looks like a straight line, but it is not. You never assume unless the question tells you. So if you have assumed AFC as a straight line, you would have calculated this as 180 minus 110 and think that this is 70 degrees. So this is wrong. All right? Do not assume unless the question tells you that AFC is a straight line. Otherwise, you cannot assume it is a straight line. Now, let's continue with the question. The question says that FCDE is a trapezium. So what's important when you read the word trapezium is to indicate where the parallel lines are. So these are the parallel lines. Okay. Now, you also see that FA is equal to FB. FA, they already marked for you, the double dash line, to indicate that it's equal. And FE, okay, also a double dash line indicated. Now, from here, you can see that the ABF is an isosceles triangle. So if it's an isosceles triangle, it will mean, let me get this. Okay, it will mean that these two angles is the bottom of the isosceles triangle will be equal. So I indicate 15 degrees to this. Now, next I can find this angle using angle in a straight inside a triangle, which is equal 180. So 180 degrees minus away 15 minus away 15, I will have 150. So this 150 degrees. Now look at the next concept we use is angle at the point F. Angle at the point is 360 degrees. Take away 110, take away 150, you get 100 degrees, which is this is 100 degrees. Okay. Now next you will notice that FEB is also an isosceles triangle. Let me use another pen. This is also isosceles triangle. The bottom of the isosceles triangle are equal. So let's calculate that. Bottom isosceles triangle 180 minus 100 degrees, which and by the way is 100 degrees. And the answer is 80 degrees. 80 degrees divided by 2, 40 degrees. So this is 40, this is also 40. Now, the question is what? The question is find angle CED. CED. So you're looking for this angle. Now I want to share with you if there's a parallel lines, which we derive from the information here, that FCD is a trapezium. So if there's parallel lines, the interior angles of parallel lines will add up to 180 degrees. So these two will add up to 180 degrees. They are parallel, which means that 116 plus these two angles will be 180 degrees. Now we already know this 40. So 40 plus this angle plus 116 will give you 180 degrees. So 40 plus 116, if I use 180 degrees minus that, these two, I will have 24 degrees, which is this angle. So that's all for question number 12. Let's continue with question number 13. So tank A has a rectangular base measuring 55 by 60 centimeter. It is filled with water to a height of 45 centimeter. So there you see, there you go, 45 centimeter. 82.5 liter water is then poured into the tank to fill it to the brim. So if I pour in another 82.5 liter, it will fill it to the brim. So which means whatever water you have inside the container plus another 82.5 will be the capacity of tank A. So what's the volume of water inside the tank? At first, 55 times length times breadth times height. That will give you 148500. So that add on to 82.5 liter that is later added in 82.5 liter. Let's change to ml. Let's make it the same 82,500 ml. You get 231,000 ml. Into liters, answer will be 2231 liters. That's answer for part A. Let's look at answer for part B. All the water in the tank is then poured into some container to the brim without spilling. Each container measuring 12 by 8 by 10. We're talking about this container. So we'll pour everything into containers, small containers like this. So find the greatest number of such containers. Very easy. First, let's find out the volume of one of these such containers. Length, breadth times height. One of these small containers has a volume of 960 ml. The tank has a total of 231 liters. Let's convert to ml. 231,000 divided by 960. You will get 240 remainder 600. Okay. Remainder 600. So we have to ignore the remainder because the question asks how many such containers. So 600 can't fill one of the small container here. So here have to ignore the remainder. So the answer is simply 240 such containers. Let's continue with question number 14. Clear this. So question 14, Jenny bought a coffee maker for $190.50 after a 25% discount. What was the price of the coffee maker before the discount? Okay, this is pretty easy. So 190.50 is after discount, 25% after 25% discount, which means it is which means Jenny only paid 75% of the original price. So 75% of the original price is 190.50. So let's find the original price, the price of the coffee maker before the discount, which is 100%. So to find 100%, there's a few ways you can do it. I'll prefer you to do this easier because 100%, there's 25%, and 75% can be divided by 25 as well. So 25% will be 190 divided by 3, and you get 63.50. 100% will be 4 times of 20%. 63.50 times 4. And answer is 254. So that's the answer for part A. Let's look at question part B. She paid $193.80 for an oven. The total discount for the coffee maker and the oven was $97.70. what was the percentage discount given to the oven? So we know from we know that the total discount for both the coffee maker and oven is $97.70. We also know that the discount given to the coffee maker is $63.50. So the discount given to the oven, will be the total discount of $97.70 minus away the discount given to the coffee maker. And what is left, $34.20, is the discount given to the oven. One moment. Okay, let's continue. So $34.20 is a discount given to the oven. And $193.80 is the discounted price. How do I know it is a discounted price? It is discounted price because when the question says that Jenny has paid, when you pay something, the amount you paid is surely, if there's a discount, and if you have paid, the value you paid, surely the amount you paid surely is the discounted price, if there's a discount. All right. So $193.80 is the discounted price. So $193 discounted price plus the discount, $34.20, you will get the original price of the oven, $228. So this original price of the oven. Question is, what is the percentage discount? Percentage discount will be the discount is given over the original price multiplied by 100%. Sorry, this 228 now, not 28. 228. Answer is 15%. Let's continue with question number 15. So let's do question 15. The figure shows a path of width 3 meters in a rectangular garden of length 34 meters. The outline of the path is made up of quarter circles with center S and center X. Semicircles with center V and straight lines. ST equal to UV equal to WX. Find the breadth of the rectangular garden. So we know the breadth of rectangular garden will be here. All right. Now, if we look at the length of the rectangular garden is made up of. Let me see. Let me use a pen. This is the radius of the small quadrant. 1, 2 radius, 3 radius, 4 radius. So it's made of 4 radius plus this. This is the 3 meter width of the path. So you can say that the length of the rectangular garden is made up of 4 radius and 2 width of the path. So let's 34, take away the 2 width, this and this, 3 and 3, and you have 28. Therefore, 28 will be equal to this 4 radius, 1, 2, 3, 4. So 28 divided by 4, you get 7. So, wait, what is this? 7. So 7 is the radius of the small quadrant. Okay, we'll clear up this one. So what is the radius of the big quadrant? The radius of big quadrant will be this, and that will equal to 7 plus 3. So radius of big quadrant is 7 plus 3, and that gives you 10. So that's radius of big quadrant. So with the radius, knowing the radius, we'll be able to find the area of the quadrant. Area of the big quadrant is equal to 1/4 multiplied by pi, given the 3.14, times the radius of big quadrant, 10 times 10, you get 78.5. Area of the small quadrant, 1/4 times pi times radius, 7 times 7, you get 38.465. So this is the area of the small quadrant. Now, if you look at the diagram, just focus on this portion. If I use the area of the big quadrant, take away the small quadrant, what is left will be this path, the path here. So use a big quadrant minus small quadrant, you get this section of the path. And there's 4 of them. 1, 2, 3, 4. So the answer, so to get the answer, it will be big quadrant 78.5 minus away the small quadrant 38.465 and multiply by 4, since there's 4 sections. 1, 2, 3, 4. Add it up together and you get 160.14. And that's the answer for part B. Let's look at question number 16. Okay, let's continue with question number 16. So Chloe baked 1,023 chocolates and vanilla buns. After selling an equal number of chocolates and vanilla buns, she had 1/4 of the chocolate buns and 1/5 of the vanilla buns left. She then packed the remaining chocolate buns into 27 boxes. Some boxes contained 4 chocolate buns, while some contained 7 chocolate buns. So how many chocolate buns were packed into boxes? The keyword in this question is the word equal. And it says that equal number of chocolates and vanilla buns was sold. The fraction given here is the fraction of the chocolates and vanilla buns left. So this is an equivalent proportion question where one fraction is equal to another fraction. The fraction of the chocolate buns sold is equal to the fraction of the vanilla buns sold. So since 1/4 of chocolate buns is left, it will mean that 4/5 of the chocolate buns were sold. If 1/5 of the vanilla buns were left, sorry, I read wrong here. 1/4, let's clear this one more time. If 1/4 of the chocolate buns were left, it will mean that 3/4 of chocolate buns were sold. If 1/5 of the vanilla buns were left, it will mean that 4/5 of the vanilla buns were sold. Since the number of chocolates and vanilla buns sold are equal, I can equate these two fractions. In the equivalent proportion concept, we always make numerator the same. The numerator of this fraction is 3, and the numerator of this fraction is 4. So the lowest common multiple of 3 and 4 is 12. So let's make each of them into numerator 12. To do that, I multiply by 4 on this. For this fraction, I get 12, 16. I multiply by 3, I get 12, multiplied by 3, I get 15. So 12 over 15 vanilla. So from this, we can see that the numerator are now equal. When you do this, the denominator will represent their total. So what this ratio meant is that there's a total of 16 units of chocolate buns at first, or baked by Chloe, and there's 15 units of vanilla buns baked by Chloe. So in the question, we know that Chloe baked 1,023 chocolate buns and vanilla buns all together. So therefore, 16 units plus 15 units must be equal to 1,023 chocolate buns. 16 plus 15 is equal to 31. So 31 units is equal to 1023. 1 unit will be equal to 1023 divided by 31. And that will give you 33. So that's the value of 1 unit. Question is, how many chocolate buns were packed into boxes? So to know how many chocolate buns were packed into boxes, we need to know how many chocolate buns were left, right? So let's focus on this fraction. Let's focus on this fraction. Let me get a pen, kind of pen. Okay, let's look at this fraction. Focus on this fraction. So in this fraction, the numerator represent the units of chocolates buns sold. The denominator represent the total units of chocolate buns baked or chocolate buns at first. So if we were to find the chocolate buns left, it will be 16 units minus 12 units. 4 units. This is chocolate buns left. So there's 4 units of chocolate buns left, which is equal to 4 times 33. So there's a total of 132 chocolate buns left to be packed into boxes. So there's part A. Now let's look at part B. How many boxes contain 7 chocolate buns? So this is actually a supposition question. You read carefully. The remaining chocolate buns were packed into 27 boxes. So some of these are in boxes of 4. Some of these are boxes of 7. So the question is, how many are packed in boxes of 7? To do that, we shall assume all packed in boxes of 4. If all packed in the boxes of 4, you will require 27 boxes, okay, times 4 altogether, 108 buns, right? But the question in our calculation, there is 132 buns. So there's a difference of 24 buns, which means that in reality, there's 132 buns. So if you assume all are packed in boxes of 4, you will only use up 108 buns. So the difference of 24 buns, which means that there must be some buns that's packed in boxes of 7. So every time there's to pack in the boxes of 7 instead of 4, you'll need extra 3 more buns. So if you use 24 divided by 3, you get a number of boxes that is packed in boxes of 7 buns. So answer is there are 8 boxes containing 7 buns each. Let's continue with question number 15. Oh, sorry, question number 17, not 15. Question 17 is a pattern question. So there are 2 types of pattern in this question. Let me highlight the one, identify what are the 2 types of question. The first pattern you can see from here is the common difference pattern. You can see that it's plus 5, plus 5, plus 5. So this one, the next pattern number 5 will be plus 5, and then you will get 29. 24 plus 5, 29. Now let's look at this pattern. You'll notice that this is 3 times 3. 9 is 3 times 3. It's a square numbers. This is 4 times 4. This is 5 times 5. 6 times 6. 7 times 7. So if it's pattern number 5, if it is pattern 5, it is 5 plus 2 square. This pattern 4 and this 6, right? So it's 4 plus 2 gives you 6. So 6 pattern 4 plus 2 square. Pattern 3 and this 5 times 5. So it means pattern 3 plus 2 give you 5 square. So basically, for this column, the formula is pattern number plus 2, then answer multiply by itself, or square the value. The pattern number plus 2, you get answer, and you square it, you get the value in this column. Okay, so this column is very simple. This column is just basically they want the number of unshaded square. So it's basically the difference between the total squares minus the shaded square. So this will be 49 minus 29. Answer is 20. That completes part A of question 17. Let's look at part B. Part B, find the total number of squares in the figure. So we are looking at this column. So earlier we mentioned that it is the pattern number plus 2 and then you square it, right? So pattern number, figure 10 is pattern number 10 of plus 2 gives you 12, and then you square it. 12 times 12, answer is 144. So the answer for part B. Now let's look at part C. What figure number was 119 shaded square? So we are looking at this column, shaded square. So this will keep going until it is 119. Okay. So how did it become 119? It actually started off from 9, and we keep adding 5 until it become 119. So let's calculate how many 5s has been added. So from 9, it become 119. It added a total of 110. How many 5s are there in 110? Divided by 5, you get 22. So we added 22 5s, or sometimes you can call it 22 intervals. 22 intervals plus the first figure number, you get the answer, the figure number with a value of 119. So this is the answer for part C. And that's all. Let me see any more question. Okay, that's all. I'll see you next week.